Anjita Pauril. Good morning, everyone. I'm Anjita Pauril, students of Master of Engineering in Mining. Today, I'm going to give my short presentations about my project topic, which is about the rock bolts and the cable bolts that are used for ground stability in underground excavations. And my research focus on improving the performance of the rock bolts and the cables bolts that are used in underground mines and the tunnels. While rock bolts and the cable bolts are common reinforcement systems that are used in underground openings such as mines and tunnels, and the traditional steel bolt work effectively but have limitations under the high stress and the fracture rock conditions. Optimizing ground properties, pretensions, and installation geometry, which improve the mechanical performance and also extend the service life of the bolts. And this studies integrates not only the analyticals but also the experimentals and the field side to optimize the rock bolts and the cable bolt designs, and also the installations of the parameters to enhance the stabilities and also reduce the cost. The given photograph is about the rock bolts that are used in underground excavations. This figure demonstrates that how reinforcement systems are installed to support rock masses and prevent collapse. From the previous studies, it showed that traditional bolts are failed to perform well in ground influence or the complex geological settings. For examples, if we see the reference of the Hyde ethos in year 1996 and the Smith ethos in the 2019, they noted that the stress and the water infiltrations weaken ground bones and which cause the corrosions. And also from the researchers like Thevin et al. In the year 2019, he noted that the ground compositions, pretensions, and bolt geometries improve the durability and the load transfer. Therefore, this study aims to develop durable, economical, and the site-specific reinforcement systems. Well, these studies have a mixed methods designs. It includes laboratory designs, improvement in situ field testings, and also the numerical modeling. In laboratory testings, we analyze the load, displacement behavior, its strength, and the ground performance under the varied stress and the groundwater conditions. In numerical modeling, we simulate stress redistributions and the deformations. All these three are combined to determine the best parameters for the performance improvement. The given figure is about the resource design methods that are used for integrating of the lab testings, field work, and the simulations. It shows how each method support the optimizations of the bolt performance in different geological conditions. There are some advantages in this research design, such as combined real and modeled data of high accuracy, and also it's allow control testings of multiple parameters such as crowd angles and pretensions. It provides the cost effective and safe approach before the field applications, and also allow site specific optimizations in complex or water affected area. uh, Even though there are some advantages in this research, there are some of the disadvantages also, such as laboratory skills may not be fully replicate field stress or the groundwater behavior. Numerical modeling depends on the assumptions and input accuracy, which also there are disadvantages of the time intensive calibrations between the lab test, institute testings, and the simulation results. To overall conclude my research, it only focused on the significantly enhance ground stability and extend bolt service life. The integrated approach ensure better safety, performance, and the cost effectiveness in groundwater excavations. Thank you.